will be discussing about the okay yeah, we will be discussing about the functions, uh, but in physics, I mean, we will be discussing about the mathematical functions. Okay, the functions maybe, uh, the term function is as well as mathematics, and it is also there in some programming languages. When if you know about Python or other programming languages, you will I think you have heard about the functions, but that function is different type. I mean, that is not the function we are going to cover here. We are going to cover about the uh, idea of function which is there in mathematics, but yes, our point of view will be from physics. I mean, whatever will be needed in physics, that will be covered. That is the idea. Okay, so let me just write down something. That is, we will cover function obviously, but not in details. Okay, if you want to study the function in very detail, then I think you will be able to understand function in very detail in mathematics. No doubt, you can, and I think you have to. If you have taken some PCM course, in that case, PCM, sorry, yeah, in that case, you have to study functions in very details. There is no doubt there. By the way, let me just start with it. Okay, so the first part is very we are just going to have just an introduction about the function. So we define function like this: y equals to f of x. Okay, this is not f multiplied by x or something like that. This is just y is a function of x. That f of x, we say that f of x. Okay, that is the right way to spell it. Now yeah, so what do we actually mean by this? Hmm? What is f of x? What is this? What is f of x? See, here x is an independent variable. Okay, and y is the dependent variable. Let me give you some very some easy examples. I think then it will be very clear to you. Suppose we say y equals to x square. Okay, so now, yeah, we say that y is a function of x, then these x square, see, that is something we are doing with x. Now x square means we are just multiplying x by itself, and whatever value we will get, that is stored in y. That's all. So f of x is just a function of x. It may look like x square, it may look like 3x by 4, it may look like e to the power x, it may look like 2 to the power x, it may look like ln x. Oh, sorry, you cannot see. Okay, okay, just I'm extremely sorry for that. Now I think it's clear to you. So yeah, so that is f of x. F of x means something, that is something, there is a function that is related to x. Okay, the function of x, that's all. Okay, so let me give you some examples of function. That is x square, y equals to x square, y equals to x cube, y equals to ln x. Then you know that log. Okay, that log, if in general, if I say that the base of the log is sorry, uh, uh, yeah, okay, if I in general say that log base is base a, and that is something, suppose x, that this log is a function or operator that is operating on x. So in physics, try to remember, in general, we whenever we are just writing the log, then we mean log base 10. Okay, and if we are just saying ln or natural logarithm, something like that, then we are just we are just meaning log base e. Okay, so that is ln x means log base e. Okay, now uh, just let me give you a formal definition of functions. Okay, just let me write it down for you. Okay, so look at the whatever I have written down here. A function is a relation that uniquely associates each element in a set. Okay, that set is called domain. So if I have just pictorially, if I want to demonstrate this in pictorial form, so let's say it's a set, and this set has many values of x. Okay, so this set, let me call it capital X. Okay, with exactly one element in another set codomain. Okay, so this capital X is domain, and the, okay, just this capital X, that is domain, and there is another set, let's say, and that contains some values of y. So let me call the whole set as capital Y, and this set is called codomain. And if there is some functional relation, I mean, suppose these are many values of x. This is just a pictorial view. Don't get confused here. Okay, and this is the codomain, and there are some values of y, and there is some functional relation, that is f. So these each value of y is related to x through a functional form. So we say that y equals to f of x. The main thing is each input should be related to only one output. Okay, so just I want to focus this point. A function assigns an input to an output in a way that each input has only one output. Okay, so for I think it's not very important to understand this pictorial representation right now, because you will understand this in very details when you will study the function in mathematics. But okay, main thing here is this part. Each input has only one output. Okay, so just let me again go to that. Y equals to f of x. Here, remember, I mean, try to recall that what did I say to x? What is the name? This is an independent variable. And what did I say about y? That is the dependent variable. Dependent variable. I mean, how am I just saying that independent and dependency? What is the dependency like? See, x I can vary. X I can vary as I wish. That's very simple. Suppose I have x. I can choose any value of x. Okay, I can choose any value of x. Any value, obviously, considering some restriction. Whatever restriction, suppose I just, when I'm uh, just mentioning that y equals to f of x, and just say that I have given one restriction that x should lie between 2 and 3. So this is some restrictions which I am imposing. But yes, between 2 and 3 you can take any value. I mean, the main thing is you can choose x, but you cannot choose y. Okay, but you cannot choose y. Y is dependent on the value of x. That is the important thing. Okay, see, whatever I'm just writing down here or mentioning here, try to understand the thing. Not, I'm just not giving any detailed mathematical approach or whatever in very detail. I'm not giving any details of it. I'm just saying you how to use it, how to use the function. Okay, okay, so now suppose one example, y equals to x cube, and I am giving you that this for x minus 1 to 1. Okay, so let me just here mention you something, that this is called closed bracket. Close bracket. Okay, this is called closed bracket. Okay, closed bracket. This is also closed bracket. I mean this, I mean just this is closed bracket. Okay, let me just when I have said mentioned this, just uh, briefly discuss about this closed bracket. Suppose I have written that x can take value from minus 1 to 1. That means x can, in the, this is the number line. Suppose this is 0, this is minus 1, and this is 1. So x can take any value between 1 and minus 1 and 1, including minus 1 and 1. I mean, we are not excluding minus 1 and 1. But if I say that x lies between this is open bracket. Okay, so this first bracket is the open bracket. Okay, so that means if this is the number line, this is minus 1, this is 1, then x can take any value between minus 1 and 1, but excluding minus 1 and 1, x cannot be minus 1 or x cannot be 1. That is the thing. Okay, so this is the idea of closed bracket and open bracket. Now just let me erase this all because this was for your information. Hmm. Coming to the main part, coming to the main part is, yeah, so if this is the function, okay, if this is the function, then if suppose I have x equals to 1, then what will be y? Y is dependent on x. How is it dependent? This is the functional relation. So for x equals to 1, y will be what? 1 cube, that is 1. If I take x equals to, okay, so I am saying that this is only, just I am just giving this restriction. This is not mandatory, but suppose this is true for only this. This is, say, just suppose this. Okay, I mean, there is no actual restriction here. So I can take minus 1 as well because it was close bracket. X can be minus 1. So y will be what? Minus 1 cube. That is minus 1. So see, depending on the value of x, the y changes. Y is dependent on x. If x is equals to 0.2, okay, 0.2 is okay, fine, because this is between minus 1 and 1. So y will be what? This. So what will be the value of this? This is 8 by 1000. Okay, in this way y is dependent on x. I don't want to complicate it further because this is very simple idea how y is dependent on x. Okay, so let me just give you some examples of functions. Okay, examples of functions. So e to the power x, y equals to 2x square plus 5x. I mean, that is dependent on x. Even y, if y is a constant, suppose y is equals to 4, then also it is a function. How? No x is there, but how can I say it is a function? Okay, y is equal to 4. I can write that 4 into x to the power 0 because we know what x to the power 0 is 1. So okay, we can say that. We can say that y equals to 4 is also a function of x. Y equals to x. I mean, you can. I think you can understand now that what by function what I want to mean. Okay. Now, yeah, one property I said you that for function, each input, each input can have only one output. Okay, by now you have understood very clearly that by input I mean x, and by output I mean y. Okay, input means independent variable, output means obviously y is a function of x. I am just giving some input of x and I am getting some output of as y. So each input can have only one output. This is very important. See, y equals to x square. For any value of input, say for x equals to 1, what I'm getting? Y equals to 1 square, that is 1. For x equals to 2, what I'm getting? Y equals to 2 square, that is 4. For x equals to 3, what I'm getting? Y is equals to 3 square, that is 9. So for a particular value of x, I'm getting a particular value of y. Here also, and here also. So no problem. This is a function. So I can say that y equals to x square. Here I can say that this is a function, but this is okay. But what if I say that y equals to plus minus root over x? Is this a function? Let me check. For x equals to 1, what I'm getting? Y equals to plus minus root over 1. That is plus minus 1. That means there are two values, plus 1 or minus 1. So for a particular value of x, I'm getting two values of y. Okay. Similarly, for x equals to 2, what I'm getting? Y equals to plus minus 2. It is plus minus root 2. I mean plus root 2 or minus root 2. So again, I am getting two values of y for a single value of x. So we can say that this cannot be a function. This cannot be a function. So that is the meaning of this. That okay, you try to remember this point very carefully. That each input can have only one output. Okay, in the beginning also, I just look at this point. Okay,